Assalamu alaikum and welcome to the new chapter. In this chapter, we are going to talk about the security in web environment and web server. So before we start the slides, this is the outline of the chapter, the topics that we are going to cover. Um, First of all, we will be identifying what is the threats and vulnerabilities, and I believe that most of you are already familiar with these terms. um, well, after this, we will go into the transportation or like transmission data and how to secure the transmission data, and also securing operating system, securing email, and and then finally we talk about like the tools that might be implemented, that can be a solution to be implemented as a security. For example, firewall, proxy server, and also intrusion detection software. All right, so talking about threats and vulnerabilities here, so we need to identify what does it mean by threat and what does it mean by vulnerability here. So you just imagine that you are standing beside a tank full of water, and in the tank here there is one crack there, and where the crack, I mean, like a crack happens to be in the tank, and then the water are actually leaking from the tank here. So while you are standing in the, I mean, like beside the tank or like leaning on the tank, there is actually a scenario of threat and vulnerability can be defined here. So the threat here, it is actually the water that will come out and flood all the place, and then and you might be sinking, of course. And the vulnerability here is that the crack that it's actually happened to be in the tank. So because this is the, I mean, like the crack here is being defined as the weakness point that may cause a problem or a disaster to be happening. And a threat, of course, the threat here, it is the nature of, like, I mean, like what is the nature of the disaster? What kind of what kind of damage that can be caused? So in this case, so here we assume that the water here will just get out and of course flood all the place. So this is actually a very simple example of of threat and vulnerability. And so, by the way, so I mean, like based on this scenario and based on this definition or terminology, many of the security systems are being built and are being considered in terms of design and development. So here, when we talk about security, there should be kind of a balancing between security and other parameters that actually ease the system. I mean, like ease and facilitate the system. For example, security can be a trade-off, can be a trade-off to simplicity and also to availability and also user-friendly. When we say simplicity, meaning that the more simple the system, it is of course the less secure will be, because simplicity meaning that we will not consider too many decisions when designing the system. So there is a high probability of, or like a high possibility that there might be a software flaw or like any kind of crack within the system, or like a bug within the system, especially talking about those kind of web services and I mean like web environment applications. Well, availability here, so the more the system is available, of course, the more security prone it will be. What do we mean by that is that when the system is always available, it means that there is actually a high possibility that attackers and other kind of, I mean, like other sources of malicious and abnormal parties may come and attack the system, causing, of course, the availability to be shut down. Of course, user friendly here, meaning that we are trying to, I mean, like to bring most of the services or like most of the, I mean, like the system functions to be appear to the user. So this will, of course, may violate maybe some of the system data that might not be that might not supposed to be available to the user. So you see all of these three, and actually even more than this. I mean, like more than this list of the three parameters, they can be all as like a trade-off with the security here. So is security something that is unwanted? No, but in most of the system applications and most of the system, I mean, like system developments, they are actually making it like a stick that can be held from the balancing point. Something like you're holding a stick from its balancing point, meaning holding a stick from the middle, trying to trying to provide that security level in the same time, of course, not compromising simplicity and availability, and ensuring a user friendly environment. Well, so focusing on threats from the internet is the main source of attack here. Here it's because attackers are really having, I mean, like a motivation. So each attacker, or like each hacker, of course, they have, I mean, like their own motivation. The motivations can be so different. Some of them, they may take it as a challenging of penetration. They wanted to challenge the systems, to prove that they are actually like with the big minds, with the big brains, trying to, I mean, like access every single digital system. Some of them, they are actually looking for valuable data, and this is actually the most important one, because here we talk about like users, I mean, like uh, cyber thefts and cyber crimes that happen to steal, I mean, and to damage a lot of data that can be like maybe belongs to a banking, belongs to whatever, I mean, like company with very valuable assets. Others, of course, they are just handling, maybe beyond the list as number three, they are handling attacks for the, I mean, like for the sake of fun. They just wanted to play around. Of course, the last type of the attackers, because they do not value the, I mean, like the how important is the, I mean, like is the victim that they are initiating their attacks on. Of course, they don't know what is, I mean, like how valuable is that victim. So in this case, they may just want to, I mean, like hack, but they are not doing any kind of thing. It's just, showing that they are doing hacking. Well, one of the hacking ways here, information can be gathered while it's being transmitted. And this is actually happens in most of the networking environment, where we can call it as an interception, where you are sending a data from client to a server, or like from client to another client, or any peer-to-peer between any two nodes. And unexpectedly, this kind of information happened to be intercepted by a third party who's having, I mean, like who is actually reading the information or listening to the channel. So often operating system flows can also assist in the hacker, because here the operating system is a point of interest, and we will be talking about this a lot in the upcoming slides within this chapter. So of course, we need to understand, in this case, we need to understand the measure of threats and vulnerabilities in the system as a system administrator. Well, so now talking about TCP/IP, and I believe that this is the most preferable place where attackers are actually initiating their attack. It is because they are actually, I mean, like once the malicious code here has been injected, of course, it is very hard to be detected. Why? It is here because, I mean, like TCP and IP happen to be designed to emphasize for ease of, I mean, like for the ease of communication. So that's why it's considered as the first vulnerability of the system. So meaning that here we are making a user friendly to be, I mean, like to be more important than guaranteeing security up to the level. But I'm not saying about, like I'm not talking about like hacking within, I mean, like the packets itself, because TCP itself, it actually guarantees, I mean, a kind of a security. But you see, in some points, if like this, I mean, like if in some other attackers, or like some other forms of attacks, the users, I mean, like the attackers also can impersonate the destination, so that they can appear to be typically as the same as the destination, where TCP actually does not is not able to, I mean, identify that this is actually a defected destination. So that's why like not all the, I mean, like not all the forms of attacks TCP can withstand and can actually be stand still against them. So that's why TCP/IP here is considered as a weakness point. So the part of IP header must also be relevant to security threats. So how the attack is happening is that by actually reading and altering and modifying within, I mean, like the header of the each message, because you see the message that is being sent over TCP/IP, it consists of the package itself. Let me see if I can draw something in here. Um, okay, okay. So it consists of the packet itself. This is the packet, and this is the header of the packet. So this is the packet, we call it P, and this is the header that it's called H. So header here, it concerns of all the information that actually identifies the packet. For example, so this is the payload. This is the data that we are actually talking about. Okay, but of course the header here is more important because the header here happen to identify the source, the destination, the packet length, the also the protocol that is being used. So with that, we are not only targeting this packet, but having information about the header allows us to identify everything regarding the transmission, and the other packets. So that's why here it is the main threat actually. These points in the header are considered as the main threat for the security here. Okay, so so the IP here, there's actually in TCP IP, as we know, there's a TCP and there's IP. IP is Internet Protocol, TCP is a Transmission Control Protocol. Okay, so the IP, it's considered as a network layer protocol. Why? It is because it actually considers and handles all the IP addressing and how to route IP addresses. While the TCP, it is actually a transport layer protocol where it actually delivers the data into the application using between the layers using what we call a datagram. Okay, so that's why here it is considered, like a transport layer, and this is actually a network layer. So here there is actually a header field. There are some important header field within the TCP itself, the TCP packet. Some of these headers are actually called, for example, source and destination port, sequence number, data offset. So usually it shows, the data offset here shows how many segments is that packet, because some packets are actually kind of big, so we need to actually segment them. So this is actually one packet, but it can be sent one, after another on segments. Okay, so that's why we use what we call data offset. Data offset is to indicate the beginning and the ending parts of the packet, so that there will not be there's nothing like a packet error delivery. So flags also can be used here in TCP. So these flags are such as synchronize, acknowledge, finish, and also this is to explain, this is to identify the state of data exchange here. So how TCP is established, this is also important, and this diagram, you will need to understand it so well. So it is very easy. In the first step, of course, the client need to send. Okay, before explaining this, let me tell you that the client, the TCP is considered a connection protocol, meaning that connection-oriented protocol, meaning that the client has to acknowledge that it's going to use the server before transmitting or before trying to transmit its request or its data here. So this is how it's happening. So in the first step here, the client has to send send an IP packet with synchronization flag, asking the user, are you interested to, to open a connection with me? Then the user replies that. So since the user sends a synchronization and also acknowledging to wait for the response here. So acknowledgement meaning that the user has accepted the connection. And finally, in the third step, so the client here sends an ACK along with the data. So here the client sends an ACK plus the data here. So the connection is open, and so that the client can keep, the client can keep joining and sending more than one packet there. Okay, so well, in the next slide here, let me just go into the. All right, so this is it. Actually, there are many attacks that are happening within the TCP, and one of the most common of the attacks here, it's called the SYN flood, because here we are talking about sending a synchronization, meaning that there is a possibility that many users are actually sending, or many clients are sending a synchronization or sync message to the server. So the sync flood here occurs when the server is receiving when the client is actually receiving many when the server is receiving many sync from different clients, and actually most likely these clients can be infected, or some of the clients here can be an attacker who is purposely sending many sync flags without waiting for the response, just only for the sake of flooding the server. So at a certain moment of time, when the server is really flooded, meaning that it's really full of too many I mean like too long queue with a sync message trying to process them, so the server will actually be disabled and will not be able to respond any other legitimate users. So it is the way of how to make the server is disabled. So here UDP is also talking about another actually protocol other than TCP. UDP is unreliable protocol. So what is the security here, or like what is the security issue in UDP talking about it in particular? It is because it doesn't guarantee the receipt of the packet. So each packet also here is being sent independently. That's why it's considered a point of interest. So again, here we say that UDP has two ways of making it, I mean, like so vulnerable to, I mean, like to the attackers. The first one, it is because it doesn't send any ACK acknowledging, meaning that any user can directly send its data and can directly seek, I mean, like open a connection with the server. And number two, it is that each UDP packet is being sent independently. So meaning that so I can take the whole data, I can take a very meaningful piece of information while just listening to the UDP, because UDP doesn't make any kind of segmentation there. Well, so another protocol or also is called ICMP. So this is for controlling message protocol, internet control message protocol. So this is a network layer protocol, also is usually used to respond to the ping requests each with echo. Echo meaning that it's just a message that's sending that yes, I'm there and I'm receiving a message. So there is one famous attack here. It is called the IP attacker, or sorry, IP scan here. More information you can find it in this page about the attack. Is that it actually I mean like some attackers are actually scanning the ports where the where the ICMP are listening to the data and tries to get the source and the destination, because ICMP is also not encrypted any kind of responding, so meaning that it's very easy for the attackers to listen to the way of the message, to the way how messages are being exchanged. So they can, any attackers who are initiating an IP scan attack, so they can actually sniff the IP and get the IP and the destination, also what kind of protocol even this can be used, either UDP, TCP, and also FTP. So for undelivered packets here, so this is how the mechanism, or like how the way ICMP works. So for undelivered packets, so this is a message that it's being displayed. So there is an meaning that telling the server that there is telling the client the destination is unreachable, is sent. So the message here is sent by that protocol, and then sending a very high so by that sending a very high number of packets, that it's actually more than the processing rate capacity of the server. This will of course slows the connection. This will of course slows the connection in the server. At the end, makes the server disabled. Okay, so about DNS also, there are two standards that how DNS is being implemented. So they are coming into bind 8 and bind 9. So bind 8, of course, this is the classical standardization of how to implement DNS, and of course within that standardization there is a lot of hiccups and a lot of issues. For example, and one of the most common of them related to security is that allowing the unauthorized user root access. So meaning that any user can has a root access, and what does it mean by root access? It means that the user has a full control of that system, and he even can initiate and can play and modify any kind of the service within the within the server. So this will cause disabling the DNS function and also modifying the IP address with an incorrect one. So that's why having a root access to unauthorized users, of course, this will have a lot of problems in this case. Okay, so binding 9, or like bind 9 here, comes into the place in order to ensure that there is actually a high level of security has been implemented. So it solves most of the issues that has been suffered. That has been suffered by the that bind 8. So it allows, especially when we talk about remotely accessing the DNS here into the computer, and also allows a kind of what we call certification authority and encryption for the certification, as we are actually seeing currently in Microsoft Server 2012, and even more than other subsequent versions. Well, vulnerabilities in operating systems. Operating systems is considered because they are so large and complex. Of course, that's why vulnerabilities there will be too much because the operating system, it contains a lot of features and a lot of services, and for sure, of course, not all the services are being developed and designed with 100% guarantee that there is no any kind of cracks or any kind of software debugs there. So vulnerabilities here may happen due to the inattentive also administrator. So this is a second reason also, or like a second aspect or directions why operating systems are vulnerable to attackers. It may come because also the administrators themselves, they are not really so careful, or they are not really handling the operating system so careful, trying to open up and trying to allow as many as possible of the services without without the need of using them really. So that's why this at the end, of course, will allow some applications to be available to attackers who may not be interested of them. So some attackers such as buffer overruns here, some attacks, these are the attacks that are available on the operating system. Buffer overruns here can allow the attacker to take over the computer here by like listening or like sniffing to the services that are being activated in the operating system. So remote access tools here also can be used to initiate a remote access and linking to the operating system by using the tool here. So this is actually a feature, a very good feature in Linux, of course. But if this feature has been activated, when the operating system is being connected to the public network, it will be actually a vulnerable point, or like a point of interest, because enabling this feature, it will allow the users to remotely access the server. So this is if the server was in the private network, that would be a very good feature. But if the server happened to be connected to the internet, of course, activating this feature will actually have a lot of like a high level of vulnerability that may allow other attackers to to link to that feature and gain a full access to the system there. Okay, another vulnerability that may come here is that having the intent to allow as much as possible of resources availability. How is that happening? It is happening by actually having a storage. Sorry, this is a has been duplicated. So it's happening by the storage mapping, or like the storage mounting. So there is actually a possibility, even in order to make a linkage between two computers, is that they are actually lying in the same when they are lying in the same network, is that to have a mount between the drivers. So if, for example, you are mounting driver C that contains the Windows on from your home computer into the office computer. So this will allow actually the mounted drive to be fully accessed by the computer, even if there is no network. So in this case, you can easily access the remote computer, the remote computer storage. So let's imagine that if in case that your computer at home is already infected by a virus, so in this case your computer and also any mounted drivers from the remote computers, for example your office computer, it will be actually also accessible, because in this case of course, like more data will be damaged and more virus will be spreaded over both operating systems. Okay, so talking about like the web servers and what are the vulnerabilities there. So here we have, as you know, two types of web servers, or like web pages on the servers. The static HTML here, these are the safest pages that can exist on the net. Why? It's because they do not have any dynamism, and they do not include any kind of programming language that it's actually a point of interest for the attackers. So the attackers here are really interested in any kind of programming language. Why? It's because this programming language, for example PHP, for example ASP.NET, or JSP, it is for sure connected to a database, and it's for sure connected to a kind of scripts, or kind of for example username and passwords. So in this case, dynamic web pages are more prone to be attacked than the static web pages. So programmers are more skilled in creating software than that are actually that works correctly than preventing the software from being incorrectly used or used incorrectly. Why is that? So this is actually a very good statement that I like to, that I have put here in the slide. It says that actually, or let me just re-explain it again. So when any programmers are programming or designing their own their own websites or application, they are really interested in having as much as possible of the feature rather than trying to considering a secure or a very authentic kind of programming structure. So it is because preventing, of course, preventing is difficult. Preventing any software, or any attacker from attacking the software, it is for sure. um, Preventing any attacker is difficult because there are more ways to cause the software malfunction than are actually making it work correctly. Meaning that the ways that making the software corrupted, it is much, much more than making it working correctly. All right. So, for example, this is a case that you can refer to. It is in page 501. You can just refer to it and and read the example there. Well, so let me just use that. It's more actually readable that I can point the cursor. Well, so okay, so moving into the email servers. So what is actually not secure in the email server? It is actually the data that are being sent, and it is the protocol that it's being used. So normally attackers are really interested of knowing what kind of message that it's being used, and also on which protocol is this message being carried or handled. So sending an overwhelming number of messages to the server, of course, will consider, will at the end causes what we call a DOS attack, a denial of service attack. A denial of service, actually, it is a very popular term that happened to be so famous these days, and actually it have many types. By the way, DOS is not only one type. It is, but if we want to define it, up to the general level, we can say DOS is any kind of attack that makes the destination is irresponsive, or that makes the destination is unavailable because of the overwhelming number of requests or connections are connecting to it. So virus can be sent over email. So how is this? Of course, by reading an email message, for example, asking the user to click on a link, or asking the user to join, or open this web page, okay, or for example, even asking the user to, for example, to send his own data. Somehow, this is actually another way of spreading an attack into the user machine. So retrieving an email over the internet often involves in sending the username and password in a clear text, especially when we talk about IMAP, and we talk about also about POP3. If you remember that one in the previous chapter, so we said that actually none of these protocols are really taking care of security by actually encrypting the username and password. So attackers, of course, can discover these data and redirect a message into into their own machine. So instead of the message going into the destination, the message will be going into another one, into another destination other than the correct destination here. All right, so let's talk about a little bit about PKI, public key infrastructure. It is actually the advanced kind of, not to say advanced, but it is somehow the second step of security that enables most of the web applications to be secure, especially when we talk about server applications, either existed on web, either existed on email also, or any kind of electronic environment. So PKI, it is asymmetric cryptography security environment, as I'm reading here, that supports transmission and delivery and script of digital communication over non-secure communication channel. So its applications are too wide here in e-government, e-commerce, e-health, in any kind of digital system. We can actually implement PKI. I'm just naming actually a few of them in here, but you can think of too many applications, any kind of security, e-banking, as we are saying, e-commerce actually here. So any kind of actually business, any kind of professional business can actually be an implementation of PKI if that application happen to be, if that kind of business happen to be professional and really and kind of a globally spread over over a huge geographical places. Okay, so what does it do? What does PKI do? It authenticates the sender of the digital communication. So it protects also integrity of the digital communication, ensuring that the data that has been sent, it's typically the same as the data that has been received. So meaning that whenever you're sending, let me just draw this. Okay, so here, so the data that has been sent from the sender, it is to be ensured that it's the same data that has been received. So when I'm reading here, for example, 1, 2, 3, 4, I mean, like, while the data is in transit, so we call this as in transit. Okay, let me shortcut it. While the data is in transit, it will be typically the same. I mean, like, it has a high possibility that other attackers, they can sniff into that. This is attack, or like kind of a malicious code, or like a malicious attacker, okay, that he may sniff into that packet, trying to read it if it happens. So if the packet is insecure, of course, the attacker will be able to read the packet here, or will be able to read the message and put or inject its own malicious code within the packet, within the packet contents. So if he is unable to do that, so then the same packet here, it will be delivered all the way up to destination, of course, using that medium. So at the end, when the packet is being read, so the packet has to have the same content as the original message here. Okay, so how to ensure that? It's by using PKI. So here, PKI, or like, let me just write this, PKI is actually being implemented here in order to ensure this kind of scenario being guaranteed. How is this happening? So this is a very important diagram. I know that it's not from your let's say the textbook, but it's actually the description of the diagram is already mentioned there, and actually even it has a very relation, I mean, it has a very high relation to this chapter. So I want you to really understand this diagram and be able to explain it. So first of all, the originator has a message he wants to send. So the message here being implemented or manipulated with the hash function. The hash function will produce the digest. Then this digest is being encrypted using the private key. So the private key happens to be with the sender. Okay, so that private key will encrypt the digest. So it will, after the encryption, of course, it will actually provide what we call the signature here. Okay, so the digest will be encrypted. So this is the encrypt. So it will produce the signature. So the signature will be attached into the message. This is the plain text of the message. The message will not be encrypted. This is a very important note. While what is the thing that that is to be encrypted? It is the digest of the message, which is the hash function of the message. So the signature here, it represents the encrypted hash function of the message. So this message will be sent over the transmission medium. When it reaches to the destination, so the destination here decrypts it using its public key, and then of course in order to get the expected digestive. So when it's being encrypted, it will get this digestive. So this is the exact digestive that it should be gotten. Of course, this is what we assume. Okay, so here the message will be also in the message will be also applied with the hash function, same hash function as in the as in the sender, and it will produce its its actual digest. So now, if we compare these two together and they have typically come to be the same, then we can authenticate, or like we can validate that this is a valid message that has not been altered. But if let's say that this kind of message has been changed somehow, okay, then this message that has maybe, for example, 2 lines or 3 lines, so then we can assume that this message is not actually authenticated message. These are the description that you can refer to. You can just read them. That explains the scenario here. So securing data transmission now, it is about how to secure data while they are in transmission. So most likely data should be encrypted. So how to encrypt that? It's by using SSL here. So let me see. So here the SSL, it is actually the most common method of encrypting data while being in the transmission. Okay, so SSH here is secure replacement for the FTP and Telnet, also FTP and Telnet communication. So SSL here, it's about encryption of the data. So SSH here, it is a secure replacement for transmission. So, well, let's talk more about SSL. So it requires this digital certificate. So that is issued by a certification authority. And I believe that we already have even practiced this during our lab when we studied about the when we studied about digital certification and how can we install them and configure them on the web server. So verify the certification authority. Of course, how to verify this by using what we call PKI, the one that we have, like the concept that we have learned just now. So it is used to define the system, the system of certification authority and also the certificates. So PKI also using public key encryption because of course it uses this one, and of course, the PKI employs what we call the public key encryption. So public key here meaning that we are actually having public key and we having a private key. So the private key or like the public key is shared with everyone used to encrypt the data. So whoever is going to encrypt the data, he uses the public key, while the private key will be kept in the server. Okay, so the server will be the only one who is owning the private key, and he's able only to decrypt the data. So only the owner of the public key has the corresponding private key. So of course here, because you see the public key and private key, they are two pair that has been generated from the server authority or from the certification authority that happen to be together in pair. Okay, so this is the scenario how SSL is being connected, how SSL connection is being created using TCP. Of course, so when we talk about TCP here, so this is a step that, if you remember here, this is the step that contains 3 steps in it. If you can go back to the slides where you have where we talk about TCP here, you see this is like a 3 steps in the first step. So when you are explaining this, I want you to go and explain all these 3 steps. So whenever you talk about the like that, creating a TCP connection. Okay, so the server sends a certificate. So after the third step, so it seems that this is the fourth step. So that's why I'm trying to clarify this. It seems that this is the first steps, fifth steps, sixth step. Okay, so SSL in details will be implemented in 6 steps here. Okay, so server sends the client certificate and the public key. So the server here replies sends the public key, and then the client accepts the certificate. It negotiates the encryption as encryption level. So it selects the encryption level either 128 or 256, or like by the kinds of bits. So how many bits the encryption should be. The encryption should be generated. So the client creates the session key and encrypts it with the public key and also send it to the server, so that this encryption key, it will be used in order to establish the SSL communication. So SSL here is by default enabled in Apache, and it's also considered in IIS and Exchange 2000, which is this one is the email. This one is the email server by Microsoft. Okay, so how can we use SSH for tunneling? So SSH is used to secure a login by replacing the telnet. So remember this. So you need also to be able to differentiate between SSH and SSL. So SSH is to be used for remote access, but it's a secure remote access, while SSL is actually being used for transmission here. Okay, so of course, as we know, telnet it's actually unsecured way of making a remote access. So, and also there are many unsecured ways of transmission and accessing. For example, POP3 is also unsecured. Why? It's because it sends the username and password in a plain text. So there is actually a way in order to make POP kind of secured. It is by using the concept of tunneling. So tunneling here, it allows you to use the unsecured protocols such as POP, IMAP4, for example, so through the secure connection such as SSH. Okay, so it makes something like like a connection, okay, from a server to destination within a secure shell, or like within a secure tunnel. So this is the tunnel. Excuse my bad drawing because I'm using the mouse actually here. So I'm trying to clarify as much as possible. So this is tunneling. Anyway, I hope that it's understandable. And this is our communication. the POP3 communication channel. Okay, so it's being used for with the tunnels with the tunneling. So tunneling here, it is actually a configuration. It's a specific configuration by allowing SSH to be implemented here. Okay. So to set up the tunneling, of course, this is the way how can we make it, and this is the way how can we make this scenario here. So configure SSH client so that the local port is, for example, I'm saying so 555 or another port between this number and of course like any kind of number above, above the 1024. So configure SSH client to connect POP3 on port 101, and then we use the SSH client in order to log in remotely to the server. Okay, so and then finally we configure the email client with the address POP3, that it's actually the local computer. So the POP server here now, it's already the local computer, using the local computer and this port number. And this is very important. Why? It's because we have already identify it to be the port number using the SSH. So in this way, we are actually linking between SSH and POP in order for POP communication to be sent over the SSH. Okay, so tunneling allow SSH client to send data from local computer through the tunnel to the POP port into the server. Okay, so how can we secure the operating system? So now talking about the operating system. So of course, security, securing operating system can be, it's not actually a single task to be. And actually there are many ways to, to do this. So let's just say that, so configuring server to do a single task, for example, mail. So this is actually, these are the considerations. So we do not want the, the servers who are running on an operating system to be like as a database and mail server and web server in the same time. So it is much advisable to make the server running as a one task server. So this will make it, more precise, and even can allow us to put, more consideration for security that doesn't conflict with the other services. Second is using a server only for a specific task. So either to be a backup, to be a main server, to be a secondary server. So it is not also advisable to use the server to be a main server and backup server at the same time, because if it happens to be attacked, so everything will be damaged and gone. Talking about like the main data or the backup data, minimizing the user accounts. So any accounts or any users who are not within the system, or who are not actually active in the system, or they have already been eliminated from the system, so their accounts should not be active and created. So they have to be disabled or removed. So disabled services that are not needed. So any services that we do not want to use them, of course, you need to close them, because this will open a points of interest and a rooms for the attacker to use them without our awareness. Make sure that you have a secure password. This is actually very common, that you need to put your password in order to access your system. Of course, the best practice of course, at the end here, we want to balance between the security need and the ease of use, as we have mentioned in the first slide. Well, so in specific now, let's just talk about how to secure Windows. Of course, considering these consideration, of course, they will apply on how to secure either Windows or Linux. But here in Windows, of course, changing the username and password for administrator periodically, it helps to secure the Windows. Also, there are many services that are not needed, as we were talking about just now here. So we're trying to minimize the services here. We are trying to minimize the online services, or the active services. So for example, here, these are the services that you may not need if you are running on a web server, for example. So Alterter computer browser, DHCP, and so on and so forth. So registry also can be used to alter the configuration. So we need to secure the registry somehow. Some operating systems are actually encrypting, or providing a next level of accessing the registry. Not all the users are able to do that, are able to access the registry, because once the registry has been altered, in an incorrect way, this will cause the whole system to be shut down. So we need to be careful about this. How to secure Linux? Linux is in fact more secure than Windows when we talk about the security. Why? It is because each service cannot be shared with a group of users, but each service can only be shared to a specific user by his name. Okay, so meaning that if we, if we upgraded that group that has been sharing the service, or having an access to the service, this will of course having a more availability, that more users are able to access the service. This is in case of Windows, but in case of Linux, so if any user want to make the service available or want to access the service, the user rather has to be identified by his name. So in this case, we are able to know who exactly are accessing the service. There are some configurations or like some considerations. You can go through them here because they're actually just as straightforward. So for example, here recommended users to be disabled, recommended services to be disabled here, as same as Windows. Of course, not all the services to be enabled, especially when you talk about like web environment. So these disables, for example, network file system in order to enable sharing, and also our login, remote login, REX, EC, RSH, and RPC. So all these are actually also remote, or the root access here, it should be disabled. Okay, so Telnet and FTP, as we have discussed before, and I believe that even this slide doesn't actually provide something new to you, I mean like to your understanding, because we have already discussed all of these actually before, especially like I'm just refreshing into your mind that FTP, it's actually and also an unencrypted, or like it is a protocol that does not practice encryption when it transfers file, or when it's being used to transfer file. So it doesn't add any encryption. And also Telnet, also it sends the username and password between the client and the server, also as a plain text. So both here are not secured actually. So SSH also here allows you to perform these tasks in order to secure both of them, either FTP or Telnet. Particularly talking about Telnet when we say that how to secure Telnet, so it is by using SSH. Okay, so in Linux, SSH here is installed by default. Also in Windows, you need to install PuTTY. So, and this is actually the differences here. You need to know that, because you see in Linux, you don't need to think of like whether you have SSH or not, but it is just only a matter of like activating it, or it's like a matter of recalling it back. But in Windows, it is not actually within a Windows body or like within the Windows features, but this is a separate tool. For example, this is a suggested tool, and it is one of the most commonly well known. It is not actually been invented or like developed by Microsoft, but rather it's being developed by another group of people who are actually being releasing it as an open source. So SSH allows you to transfer FTP file in a secure environment using SFTP. This is the way that how FTP can be configured in order to be secured, by adding the SSH configurations in it. Okay, so securing email servers here. They are configured to be, of course, usually email servers are the most services available on the internet that allows availability as much as possible, because simply if you want to send an email, you should be able to send an email to anyone. You do not want the email server to tell you that, oh yeah, you cannot send an email to that particular person, for example. And or like you are receiving an email from anyone, at the end you are just surprised that the server, or like you are receiving a message from the server telling you cannot receive from this party. Okay, so in this case, most of the email servers by default I'm saying, they have to be configured for availability. So taking these default settings into the web environment, of course some attackers will exploit this benefit, like in a bad way, in a negative way, in order to listen, in order to to sniff the message, or in order to keep sending a fraud emails, or like a lot of spams that are actually like trying to convince the recipient that these are actually kind of a good messages, so that whenever they click on it, so you'll be actually infected, or like your computer will be hacked somehow. So also, the complexity of the email agent, or like the email client here, plays a role in this case. So because once the email agent, or like the email package here, it's kind of complicated, such as Microsoft or like Windows Exchange, and also send mail. So in this case, it will be very hard to be administered and very hard to be controlled. So, and also to configure. So a lot of misconfiguration incidents will be happening here. So this may actually also treat or like open as security a threat here. So as an alternative, Qmail happens to be the most safest. I mean, like the safest alternative for, I mean, um, like to say a web or like an email, sorry, an email agent or like an email package that it's being used in order to make a communication. It is also very light and secure. Well, so Exchange 2000 also can also be used with SSL for protocol. It's more secure. So this is like I mean like a configuration that happens to be between I mean like the Exchange and SSL in order to provide more security. So what are the kind of or like what are the forms of attacks that happen to be in the email? These are three of the well-known forms of attacks here. Either talking about large email message, sending large email message until the disk is full, we are trying to exploit the disk, or using an email sent to the virus, for example, containing a link, or email spoofing by itself. So we are actually sending an email, and in order to sense I mean, like the IP address of the user, once the IP address replies back, so we are initiating a backdoor communication in order so that if the user later on, if like the destination later on that we are connecting to as I mean, like me as an attacker, if the destination that it's connected to later on, it is not. I mean, like it makes a communication. So me as an attacker, I will be able to spoof because I have already sent a message and I have get a reply from that user, so I'm able to get all of its data. I mean, like I'm able to get all of its I mean, like interface or like networking interface data. Okay, so securing the web server. Again, here we are actually saying about like we need to enable the minimum feature as much as possible. So we do not want all the features of the web server to be available. Like for example, whether you want to allow console, whether you want to allow, for example, DHCP, and any other, I mean, like kind of features that can be in the web server, server mirroring, also backup, and all of these things. If they are not needed, they have to be secured. So make sure that programmers understand the security issues. It is not only about programming. It is not only about creating web pages and web servers applications, but rather we need to take care of I mean, like what are the security issues whenever you are creating a web page or like any kind of application. So we need to implement SSL in order to encrypt sensitive data here. So we need to follow up the product review also by the users and the experts, particularly from the experts and also from any kind of bad user experience, trying to explain what is the situation or like the incident situation that happened to be occurred for those users who have been infected in their I mean like in their usage of the email server. So how to secure, these are actually three steps how to secure Apache and Exchange: by using SSH, by controlling the user access, meaning that limiting the user to the server, and of course by checking and delete the specific virtual directories here, because virtual directories they are not actually visible and they are only about configurations. So it's very easy for the attackers to I mean like to make use of these kind of virtual directories and also virtual machines somehow. If you're actually creating a lot of virtual machines and you don't know how, and you are unable to admit to all of them, so one of them it might be a point of interest to be an attacking point there. So tools that can be used by Microsoft Exchange. These tools are actually in order to how to scan and how to actually provide an information if there is a server. I mean like if I mean like about the server and its data. So URL scan, it keeps the harmful pages request away from reaching the server, and also lockdown, it's to adjust the security settings based on the server rule. So it is about like changing the security settings that actually matches the nature of the server, how the server is being used, whether to be a database or an email or a web server. Okay, so here configuring the user authentication. Of course, user authentication is the main step in order to guarantee security. And you can just read this information. I'll not just go through with you and one by one in there, but you need to understand from security, I mean like from authentication, is that it is the main step in order to provide, a security to any system. That's why in authentication we have four types of authentication of authenticated access. How can we access users? Meaning that because definition of authentication is to to limit the access of the users by having by allowing each user to provide its own credentials. So here, as the first type, Windows integrated authentication. Uh, for example, it's the most secure approach here. It uses a cryptographic exchange that can actually authenticate user without having a password. Okay, so by sending to the server. So it requires Internet Explorer here. So meaning that the authentication should be actually over the internet. So digest authentication for Windows domain servers. So it sends encryption login data into the server. So meaning that the data should be sent to the user. It works with proxy servers, and it requires Active Directory and Internet Explorer. So Active Directory in order to manage the different domains. And you see, if you have like more than one domain and you want to actually to be authenticated to use another domain, so that's why Active Directory has to be used in here. So the basic authentication here, the basic authentication is username and password are sent into the clear text, and this is the unwanted kind of authentication, of course. And a password authentication, it is like authentication on run, meaning that you're authenticated as you go. So centralized form authentication supported by Microsoft, only available for Windows Server 2003. And this is actually not also recommended, but if you have an application that you do not want to have a lot of complexity there, so you can just have a passport authentication. Or if you have a service that it's not permanently being developed or deployed, meaning that you are launching that service for a temporary time, so you can use kind of passport authentication. Okay, so using a firewall, so it is of course one of the well-known tools in order to invoke security here. Firewall, it's about rules and it's about like how to access. Some people are calling it an access control policy, and yes, it is right, because it has, the nature of it is to allow as much as possible of users, internal users, to access the outside networks, while not the way opposite, while not allowing as much as possible of the outsiders, those users existed on the internet, to allow, to access the internal users. So allowing in to out, but not allowing much of out into in. Okay, so you need to limit the access as what we have said in here. Restricted, it restricts access to the web servers. Okay, so because these kind of places are sensitive, so not all the users are allowed to access these places, and also allow access internal users to the internet. Types of firewall, or types of filtering in firewalls. Okay, so how firewalls are being filtering data. So allowing access, it actually happens by filtering, because you see how they use, how the firewalls detect that this particular user is not allowed. It is actually by integrate, by sensing the packet, from which user it's coming based on its IP address. So it actually blocks the user based on either its IP address, based on the protocol that's being used. So all of these are actually being captured by the firewall. So okay, so the filtering types there. So packet filtering, of course, it looks as what we have said just now into the packet of each user. So based on the rules, it determines whether to let the packet go, or whether to let the packet to pass through the firewall or not. So most likely the firewall used to be implemented before the user is accessing into the data, into the internet, or into the sensitive server. So let me just give you a little draw of this. Well, it's here. So imagine these are the users. I'm just drawing small figures in here. So okay, so these are connected to a switch. So this is a switch, and of course the switch have to be connected to a firewall. So a firewall is actually either can be a separate device, or somehow it used to be a plugged in. It is used to be as a software that it's actually plugged in within the router itself. Okay, so this is the firewall. So it's either connected to the server pool. Let's say, for example, this is web server. This is the database server. And also here, this is the internet. Okay, so this is the internet. So the firewall happened to be here. So this is the best place to place the firewall. Why? Because we do not want the users to access the like the valuable data here that happens to be in the servers, and also we will not allow the users from the outside to simply access the data here in the like in the sensitive places. So okay, so circuit level filtering here, it controls the whole session of of communication. So it is actually whether to decide stateful or dynamic filtering. So it allows traffic to be initialized from within the organization to the return. So however, it restricts the traffic initialization from outside. So meaning that it allows internals to access outsiders, but not outsiders to access internals. Okay, so application level, and this is actually the best type of filtering because it filters based on the application. And nowadays, because we have a lot of applications and a lot of users and a lot of traffic applications, so in this case, we are able to identify which kind of data we want to access or which kind of data are allowed. For example, I do not want the internal users to be able to like to listen to these kind of heavy applications. For example, video applications, okay, or for example kind of voice applications. So in this case I'm actually filtering based on the characteristic of the packets. Okay, all right, so packet filtering firewall also, this is actually this is the last slide, by the way. So this is just a simple like definition of like what does it mean by packet filtering, because this one is actually the most classical kind of firewall, and most of the firewalls are actually being defined as to be a packet filtering. So it consists of a list of acceptance and denial rules, so whether to accept or deny. So IP tables utility here, it's a command line utility. It is used in order to trigger these kind of rules. So by actually creating a script, so these rules are being created within a script, meaning that written in a script and then being installed into the firewall so that they can be implemented to all the users. So firewall independently filters what it comes from, what comes in and what goes out. Of course, we are repeating actually this. So it is the best. It is best to start with a default policy that denies all the users, and then after this you can decide who you want to allow and who you want to give an access to a certain type of devices. So three types of packet here. We talk about TCP, we talk about UDP packets, and ICMP. So TCP, it's a packets that are actually coming from, for example, from HTTP. Packet can be a text packet. So UDP here, a multimedia packet, can be a voice packet, video. ICMP, it's like a message packet. So all of these are actually different packets. So we can reject or drop the filter packets. So you can actually reach to the like to the page 533 in order to get like more examples and how like and more understanding of the like the description in there. So either it can be a drop or it can be a reject. So whether to throw away the like away without the response, without responding, or to simply reject, for example, ICMP packet. So it sends like a rejection response to that packet. Okay, so with that, we can summarize our chapter. And if you have any further point, please just do ask me in any of our discussion groups, and I will thank you for watching, and we'll see you in another video. Thank you so much.